In this video, we are going to learn how to use division to create equivalent fractions. I already know that I can start with a fraction and multiply by another fraction that's equal to a whole. So for example, I can take 1/2 and multiply it by 2/2, and I get my answer of 2/4. Notice that we doubled the number of pieces. I could triple the number of pieces by taking 1/2 and multiplying it by 3/3. So instead of just one piece, we now will have 3 pieces out of 6, 3/6. I could find another equivalent fraction by taking 1/2 and multiplying it by 4/4. We have 4/8. I could take 1/2 and multiply it by 5/5. 5/10 is equivalent to 1/2. I could find another equivalent fraction by multiplying 1/2 by 6/6, and that gives me 6/12. So here are all of the equivalent fractions that we found. Notice every time we multiplied, the pieces got smaller and smaller and smaller and smaller. And I could keep going. I could multiply 1/2 by 10/10, and I would end up with 10/20. Those pieces would be really small. So what if we started with the amount 6/12? We could use multiplication to find equivalent fractions. Every time we do that, the pieces are going to get smaller and smaller. So now we're at 12/24. If I did 6/12 times 3/3, that would equal 18/36. And you can see how these pieces will just keep getting smaller and smaller. What if I wanted to find an equivalent fraction that used bigger pieces, not just little tiny pieces? What's the inverse operation of multiplication? The inverse, or the opposite, of multiplication is division. So what if I used division? What if instead of multiplying, I divided by a fraction amount that's equal to a whole? I could do 6/12 divided by 2/2, and I'll divide the numerators. 6 divided by 2 is 3, and 12 divided by 2 is 6. I get 3/6. And our fraction bars show that it works. 6/12 is equivalent to 3/6. With the amount of 6/12, we actually divide by a couple more options. With multiplication, we could multiply by any fraction amount that was equal to a whole. With division, it has to be equal to a whole, but the numbers also have to be able to divide. So for example, I wouldn't be able to just randomly pick a number like 5/5, because 6 will not divide by 5 and 12 will not divide by 5. So that won't work. So we have to think about our factors. We have to think about numbers that 6 can be divided by and 12 can be divided by. I know that 3 times 2 equals 6, and I know that 3 times 4 equals 12, so I could divide both the numerator and the denominator by 3. So if I pick 3/3, that should work. 6 divided by 3 equals 2, and 12 divided by 3 equals 4. And it works. 6/12 divided by 3/3 equals 2/4. There's one more possibility that we can divide by. What about 6? 6 times 1 is 6, and 6 times 2 is 12. So if we divided by 6/6, we could come up with another equivalent fraction. 6 divided by 6 is 1, and 12 divided by 6 is 2. So that gives us 1/2. 6/12 and 1/2 are equivalent. Now notice every time I used division, the sizes of the pieces were bigger. So we went from 12ths to halves. Look how big that half piece is. Back here, when we did 6/12 divided by 3/3 and got 2/4, look at how big those fourth pieces were. When we use division, we're finding equivalent fractions with bigger sized pieces. Since the pieces are bigger, they're easier to count, they're usually easier to visualize. We say that that's simpler. So it's a simpler form. So sometimes when we're talking about dividing to create an equivalent fraction, you'll see in the instructions, simplify your answer. And that means that we're using division, we're making bigger sized pieces. Let's use division to make a fraction that's equivalent to 4/6. I notice that 4 and 6 are both even numbers. So that means I could divide both the top and the bottom by 2. So I'll choose 2/2 as my fraction. 4 divided by 2 equals 2, and 6 divided by 2 equals 3. I can see that 2/3 is equivalent to 4/6. Let's take a look at 4/10. Again, I can see these are both even numbers, so I can choose 2/2. 4 divided by 2 equals 2, and 10 divided by 2 equals 5. 2/5 is equivalent to 4/10. What if I had 5/10? Now I can see that 5 is an odd number and 10 is an even number. So I'm not going to be able to divide by 2/2 because 5 won't divide by 2 evenly. When 2 won't work, we have to be able to find another number. One strategy is to think of the factors of 5, think of the factors of 10, and find a number that's a factor for both 5 and 10. This is called finding a common factor. And we usually just make a list of the factors. You can make a T-chart. You know that 1 times 5 is 5. 2 is not a factor. 3 is not a factor. 4 is not a factor. When we get to 5, it's already on the list. So 5 has 2 factors, 1 and 5. Now I've got to think of the factors of 10. And you might be able to just list these out. I'm going to make a T-chart just in case we need help remembering what factors are and how to find the factors. So we know 1 times 10, those are both factors. 2 times 5, those are both factors. 3 is not a factor. 4 is not a factor, and 5's on the list. So 10 has 4 factors, 1, 2, 5, and 10. Do you see any numbers that are on both lists? You might have noticed 1 is on both lists and 5 is on both lists. Now 1 is always going to be a factor. Watch what happens if I divide by 1/1. I end up with 5/10. So I really didn't find an equivalent fraction. So we want to pick a number that's different than 1. Let's pick the factor of 5. Let's divide both top and bottom by 5/5. 5 divided by 5 is 1, and 10 divided by 5 is 2. So using this method, we were able to find out that 1/2 is equivalent to 5/10.